All right, so welcome to the Training Center of Air Conditioning and Heating. I'm going to give you a tour, and we'll kind of give you a show of what we do around here and what makes us different. Let me start by just telling you who I am. My name is Chris Walters. I've been in the AC business for about 40 years. I run my own AC company for many years, doing commercial and industrial and basically anything that's out there that has to do with refrigeration and or air conditioning and process heating and cooling. I have a Class A license. I'm considered an expert by the state in this trade. Have been many years as a volunteer on the state license committee. So a few years ago, I decided to close my AC company of many years and open up an AC school. If you don't know already, in the AC trade, there's a tremendous shortage of technicians, and this shortage has existed for my entire 40 years, and it's going to exist for a lot longer because the average technician is getting, retirement age, and he's going to retire away, and there's not many people coming to take his place. So it's a great trade to get into. It's basically recession proof and here recently even pandemic proof for the most part. So it's a good place to go. I want to give you a tour of the facility, let you kind of see why we're different. I know there's other schools out there. I also know that the other schools don't do what we do, because that's the reason that I started this school. So I'm hoping that this tour and this a little follow-up to come after the tour is going to kind of show you why our method is different and what we do to kind of set ourselves apart. So this is the facility, and we're going to kind of go through it slowly. Right here on my left, I want to show you what we call our skeleton unit. When you come into our class, we've taken this, basically it's a house AC, and we've skeletonized it to its most basic form. So you can really see that there's only about 6 components in here that are that make the difference, that kind of make the meat, the basis of the AC system. So we want to break it down into this most basic form to where it's easy to understand, it's easy to see, there's nothing in the way, there's no panels or covers, and we can plug this in and this works. And within a couple of days of you being here, you'll know everything that's going on inside of this tubing. You'll know whether it's a gas, you'll know how heat is being removed from inside of a home and rejected to the outside. You'll get all of that, and you'll get it in a depth, in a way that most people don't get. So you'll become a very good troubleshooter, and you'll have a very good understanding. That transfers to the customers, and that transfers to people when you're telling them what the problem is. Your depth of understanding means everything in this trade. So we use a lot of things like this. A lot of unpolished, made in class props, if you say, and these props make such a difference in how you understand. I'll show you, if we'll turn over here just to this bench, and I'll just show you a few more things that I'm talking about. We have stuff like things that most people will go their whole career and they'll never get to see inside, like this reversing valve right here. We like to cut everything open. If we cut it open and you're able to see what's going on inside, you can see the components, it makes a huge, tremendous difference. And when I say everything, it's pretty much anything that you might deal with in the field, in this trade, we're going to cut it open. We're going to have sliced it open so you can see the inside workings. We're going to make sure that if anything ever happens, or if there's a reason that we're telling you not to do something and there's a bad result that could occur, and we've got a piece like this piece of pipe that blew up because moisture stayed inside of it during the brazing process, we're going to make sure we provide all of that for you so you can see it and learn from it. Even if there's demonstrations that we can do that show that there's a reason to put nitrogen in copper when we braze it versus, if we put nitrogen, look what happens. If we don't put nitrogen, look at all this oxidation. If somebody pays the money that they pay for a new AC system, and you don't take this step that's just, it's really a $2 or $3 step, and from day one they get this oxidized copper, you really haven't given them what they paid for. So if we could prove that to you and show you there's a good chance you're going to do it the right way. You know, talking about things that we've taken apart, capacitors, this would be one of the most common things that would ever break in an AC system, probably, 60, 70% of the time. So we're going to make sure that we've opened those up. When they fail, and they fail different ways, sometimes, the tops will blow off of them, or they'll bulge or what have you. We're going to make sure that we've always got pieces for you to see, samples, clear samples, parts to mess with, anything that we can do. Even when we're testing, we're going to make sure that we have enough test components for everybody to not be, sharing. We can pass enough stuff around. Everybody can do their own thing. Up here, I'll pull down a few more things that we've cut open that normally in your career you'll never get to see inside of, such as this receiver here. But when we open it up, we make sure that you can see everything, so you understand what's going on inside of it, even if it's something as simple as a tank, a refrigerant tank or a flush tank. And if there's a dip tube in here, there's something more to see. If I have a tank like this without a cutout, I don't really know what's going on. So we want to make sure that you can tell the difference if there's a dip tube or not. It just makes it the understanding that you get a whole lot better. So those are some of the efforts we take. A few more things that we've cut out, and I'll show you, would be like a set of gauges, something that you would use a lot in your career. But we see that if we let you see what's going on, then it makes a lot more sense to you what's happening if you can see what's going on inside the gauges. Even things that like dryers, liquid line dryers that you normally, you go your career and you buy this dryer and you don't know if there's a difference between this one and the gray one and different brands. So you just kind of pick one up off the shelf. But we would like to be able to let you see what's going on inside of them. If you see inside and you can tell, well, this one's got a solid core versus a non-solid core, it might make a difference to you on which one you choose. So there again, it goes back to us wanting to take any effort we can to show you the inside of things. One thing that we opened up recently was an acetylene torch bottle. And we bought this bottle and opened it up because there's some real unique features in here that during our torch class we explain. Once you can see the inside and we can explain to you why they did this, basically, and then it makes sense to you when we tell you to keep your torch at a particular setting, and why, if you don't, it could be dangerous. So our goal is to make sure that we're always showing parts, opening things up, and letting you see exactly what most people don't get to see. So I'll come back over here. When you come into the class, typically what happens is the instructor will be out here in the middle, and we're always, the way we have this U-shaped setup, we're never more than 6 or 7 feet away from you. So since we don't have a high class density and we don't put a lot of people in here at any one time, I can get to everybody, regardless of who it is. Everybody can hear and see. Everybody has the best seat in the house. So that works very well. As we get into the different subjects and we get into heating, we'll have another prop that we'll pull out. And it could be something like this, where I might have taken a gas furnace and may have opened it up to where you can see things that you don't normally get to see. What's going on the inside of a gas furnace? What is it that I normally is hidden from my view? Normally on the gas furnace, we get to see this only, and we wonder what's happening behind the panels because they're not removable. Well, in here, we can open those panels up for you and we can take all the mystery away. There's really nothing going on back there, so you can quit worrying about it and focus on the front. If it's an electric heat unit, we have the same kind of mock-up made to explain how simple electric heat can be. And on top of all of this, we have the ability then to go into all of these things very deep. And if we start out very simple and we get the basics, then we can dive into it deeper. And I mean deep in the point where we can give you formulas, you can calculate heat rises, and you can tell how much air is actually moving by the heat rise, various things like that. Even the skeleton unit, we got all sorts of charging techniques that are manufacturer recommended techniques like superheat and subcool, and things that a lot of technicians don't really pay a lot of attention to. mainly because they don't understand or they've never had it explained to them in a way to where it just completely makes sense. And that's our goal, is if we're going to tell you something, we would encourage you to say, tell me why. Why should I do that? We like that. Okay, we even like it if you question um, the method or the reason, any of those things, because we want you to be a believer in the reason that you might want to check this heat exchanger, or the reason you might want to check amperage on this unit, or the reason why there's another method of telling how many watts this would be just by using Ohm's law. We need you to know all that. And if we can do a good job, then you'll be a believer and you'll actually do it. So we'll move around here a little bit to this other side. And if you notice, as the camera kind of rolls across the building here, you notice that it's not a big place, but every inch of this building has been maximized to where there's not a wasted wall, there's not a wasted surface in here anywhere. Even on the floor, we've got a condensing unit on the floor. We've got a lot of these things. We've got things in the cargo container that we can pull out during various parts of the class. We can make sure that you get to working on the real things. We've got a lot more. We've even got the things, the units that cool and heat the shop, right? So the furnace, the gas furnace that's here that is actually in use, you know, every day while you're here. This is something we use for demonstrations. We actually teach static pressure. You can't determine how much airflow is moving through a duct system if you don't understand static pressure. So we do a very good lesson on static pressure, and we can make it make sense where you'll probably be one of the few people out there using it, but it makes a ton of sense and it's entirely necessary. So not only that, but if you notice as you're looking around here, you'll see that we've got tons and tons of supplies. We have supplies for whatever class we're teaching. We have enough supplies for you to have your own supplies. Okay, not to mention everybody that comes into school, they get a textbook, they get a workbook that we've designed, they get a bag of tools that has the tools you need to take the class, which is gauges and meters and various hand tools. And as long as your safety equipment, you get that too, your gloves and your glasses, your pens, pencils, paper. Basically, if you just aren't wearing sandals on your feet, you got some sort of closed toe shoes, you walk in the door and we have everything else. So that's kind of our goal. Up here, what I've got up here on these benches and shelves is more props, more things that we can use. Basically, this is a window unit. We can plug it in. We can show you the cycle. We can show you how heat gets removed from one side of the window and sent to the other side. Very simple process, really. And we can make it even simpler the way we show it. We have demonstrations such as this vacuum chamber here. We can put water, a cup of water in that chamber, and we can pull a vacuum on it just like you would do in an AC system. And we can have water that'll actually start to boil at room temperature. Instead of the normal have to put it on the stove and boil it at 212, we can actually watch it boil at room temperature. And this is a good demonstration of how we remove moisture from an AC system by pulling a vacuum. And then you can actually see in front of you how it would work, even though you can't see it normally. And we can do those same demonstrations with refrigerant. If we tell you that refrigerant boils and absorbs heat, we can hook up a thermometer, we can put some refrigerant in a can, we can let you watch it boil and absorb heat right in front of you. So the process of walking up to something that typically becomes a kind of a mystical thing, something that you just are told it works this way, we don't like that. We like to be able to show every single function. Up here, you'll see more displays, motor displays. We want to be able to prove if we tell you you need a particular component on a motor for it to work, then we want to have that set up to where we can turn that component off and on, and you can see why that component's important. And we just go on and on with more things. If we're telling you how to remove a core while a unit's running, then we want to have a core removal station where you can actually do it. And then we'll do it in a manner that's safe for the environment. So if you make a mistake, we want you to make the mistake in here. If you make a mistake in here, then it's probably not going to be as bad as out there. Number one, it's our equipment. Number two, we probably hooked it up to where it doesn't hurt anything. If there's any kind of different components you need to know about, we've got it. We've got it cut open. We've got a way to show it to you. Even things like a coil. If you want to know, if you've got an evaporator coil or a condenser coil, and we're talking about the different types and why one might hold refrigerant more than another one, and why a critical charge could become important, we've cut them open for you. We can demonstrate it to you and let you see that yourself. So as I move around here, you'll see that we've just got more things. We're moving into the compressors, right? So this is the heart of an AC system. These would be the most expensive part in the entire AC unit. This is a part that shouldn't burn out. It should last 20 years. So we want to make sure that you understand and you can see inside of them. You can see how they're made. You can see that this component is very heavy. It's made like a car engine. It's made to last 20 years. If something like that is supposed to last 20 years and it lasts 2 or less, then you're going to be thinking in your mind, why did it go out? And that's going to make you a better service technician as well. So we wrap it up here. We've got some duct work up on the top. We got the ability when we get into duct class, we can really do a good job of showing you how to not only put duct together, but all the codes and all the common code violations that go on with duct. And a lot of the violations that occur are just simply because the person doing it just doesn't know better. We've even picked up and put on the board all the different code books that affect the AC business. One thing you may not know, and we teach in here a lot, is we want you to be skilled in the knowledge of all the things you need. So if you're going to be in this business, then there's certain books that you need to be aware of. There's certain codes that you need to be aware of, and then you need to really be aware of the things that you don't know. So as you go on in your career, there's advancements in here you can take, and you can take, number one, you can get a certified technician status in 2 years. You could actually get your license in 3 years to where you could open your own AC company. So those are all very positive things. I'm going to move over to this side here, and what we're going to do is we're going to pause it so I can flip the camera around and show you some stuff that's going up on the side, and then we're going to come right back. Let's see if we. So we're talking about some more things in the lab and the shop here, and even if you're able to see up here over my head, you can see where we've got a lot of posters and various information. Most of the graphics that we do here, we do ourselves because we really want it to be just straight from the heart and straight from our knowledge. So we're real big on proving things and props and charts and doing it. What I've got moved up here now is I've got a big AC system that's it's actually a heat pump system. And this is another one of our props that we bring up and we're able to demonstrate, let all the students come up and they can touch it and see what's going on. Everything in here, you notice, has these tags on it. So a lot of things are tagged and we have numbers on the tags. And we call this our tag testing. And like all tests in this school, the test is really self-graded. You grade your own test. It's not about us telling you missed anything. It's about you knowing that you need to work on something. So whatever we do here, you're going to grade your own paper. You're going to look and you're going to say, hey, I need to brush up on that particular thing. But on a prop like this, we're able to turn it on and we can run it. We can hear it. We can manipulate it. We can let you come up and play with it. And then you really start to understand it when you can touch it and feel it. If I'm touching the lines and the lines are getting cooler or they're getting hotter or I'm seeing liquid flow, I'm feeling changes in air temperature, I'm feeling air movement, I'm seeing inside of it, it makes me understand it a whole lot better. So this is kind of the purpose of all the props that we use in here, is that you're able to get to see a real AC system. I've got another one right behind you. Shane, if you'll hand me that little unit right there, I'm going to bring this unit right here and set it on the bench and plug it in and let y'all see this. This is a small, what would be like a window unit, a very small window unit. And we just recently made this prop so that we could demonstrate it as well. And what you'll see, and I'll be able to flip it up a little bit, is we took what was a small unit and busted it apart and put it back together. We have the ability of turning it on. Okay, so now it's running, and if I hold it up where you can see all the components, you know, the compressor. So basically what you have, we have a part of this will be our outside part of our AC system. Part of it will be the inside part of the AC system. Like all AC units, all we're doing is we're just removing heat from one thing and rejecting it to the other. So it's very simple. It makes a lot of sense if there's things like this for you to come up and touch. If this one's getting warmer, we know we're sucking heat out of here, moving it out here. We can even do this with buckets. We have the ability of setting buckets on top of the table right in front of the class, and we can move heat from one bucket to another bucket right in front of you. No fans, no pumps, no moving parts, just with a simple compressor like this. So those kind of demonstrations is what really makes a difference and sets us apart. We're going to roll back in the back, so we're in the back lab. This is the lab where you get to do a lot of one-on-one testing with equipment. We've got 8 machines back here. Each one of them is set up for you to do all sorts of testing. And we're talking about hands-on testing where you're actually sitting here, you and the machine. You're going to be either doing things like taking out fan motors. You can see some of these are outside. Some of the condenser units are outside. We want it to be as real as possible. You might be outdoors working on it. You might be sitting in here working on it. And when I say working on it, I mean actually working on it. These are not the props that you set up and you just look at. These are things you take apart. You actually take the fan out. You actually take the blower out. You take the readings. You take all sorts of performance testing and amperage testing. You actually take the wires off, all of the wires out, and you put them back on from your skills, not from looking at a wiring diagram or a photo. And as we just go around the room, you can see that we've got quite a few of these. They're all set up to where they show you what you need to know and what you need to see, and let you work with different refrigerants and kind of dispel the rumors and the myths that, you know, there's only one refrigerant that works, or that if a unit breaks and it has an older refrigerant, we got to replace the whole AC system. That's just simply not true. So you can see in here, we got 8 of those units. This lab works very well. You get a chance in here to spend a lot of time on hands-on. This is where towards the end of the 14 weeks that you can come in here and you can really hone your skills. Remember, a lot of this is going to be kind of a muscle memory thing. So after you've done it one time, after you've seen us do it, then you need to do it several times. Different machines, different settings, different type of configurations, different refrigerants, and that's where you start gaining your muscle memory skills that make it very unclumsy for you when you get out in the field. So that's the back lab. We'll pause and move again. Ready whenever you are. Okay, so we're continuing our tour, and at this part, I'd like to just kind of give you a very limited, very short sample of some of the things that you would learn. So I want to start out with just kind of explaining that everything we do, we follow our own workbook. You know, we made our own workbook, and we use it because it makes sense. You know, it makes sense to follow it in the order in which we follow it. Now, the demonstrations I'm going to do today, they're not necessarily in that order, but I want you to know that when we give the class, we follow an order that makes complete sense. It doesn't stay on the subject long enough to like get you bored or wear you out on it, but it stays on it long enough to get you the meat of it. We might move along into some other things, and then we'll come back and go in a little deeper. We always come back. That's one thing you need to remember. In this class, we will constantly come back to things you've learned at the beginning, reinforce them, dig a little deeper each time, and it makes more sense than trying to hit something new and just, hammer down on it from the beginning. So one of the massive and major principles of AC is being able to change a liquid into a vapor, or change a vapor into a liquid. Those are two things that we do every day, all day long in this field. We have to know that it's those changes that cause us to absorb heat and to relocate it somewhere else. So if we take a liquid, any kind of liquid that has a low boiling point can be a refrigerant. If we take a refrigerant and we cause it to boil, like we put it down to some atmospheric pressure, we take it out of its can, out of its tubing, out of its pressure environment, and we let it go to a low pressure environment, it's going to boil. Now, as it boils, it absorbs heat. So anything that it's touching, it's going to take heat out of. So if it's touching coils or copper and it's taking heat out of the copper, and we're blowing air across that copper, the air is going to give up its heat, and then the air is going to come out the other side cooler. So we don't make anything cool as much as we remove heat. We remove heat from the copper removes heat from the air, and the air feels cooler. So then when we take that heat out, we have to get rid of that heat. So we take that heat outside the house and we get rid of it with the outside unit. If it's a window unit, we take the heat from this side of the room that we're in, and we put the heat out the other side of the window. If it's a refrigerator, we take the heat out of the produce in the refrigerator and we blow the heat out on the floor of the house. So it's all about moving heat. Well, the only way we can move heat is we first have to absorb heat. So I want to show you just a real simple little demonstration of how a refrigerant will absorb heat when it goes from a liquid to a gas. So you can see the thermometer set up on this little metal can, thermometer on the bottom. You can see that it's 69, just went to 70 degrees. I'm just going to put some liquid refrigerant just in the can. That's boiling. What you're seeing there is you're seeing the liquid refrigerant boiling. As it boils, it's turning from a liquid into a vapor. The vapor's going up here. As it turns into a vapor, it's taking the heat with it. The heat is leaving this metal can. The heat is gone. The heat is in the vapor, left. Okay, so in a refrigeration or an air conditioning unit, we do this same process within the tubing, but we keep the vapor. We send the vapor back to be turned back into a liquid after we get rid of the heat. So I think you can see on your gauge here now, it's quite cold. It'll actually has no problem getting down to 10 or 20 degrees below zero. As long as there's something in there to keep boiling it away, it'll keep soaking up heat. So this is a really good demonstration on how a refrigerant can absorb heat as it changes state. So we talk about the change of state a whole lot in this class. We also want to move over, and I want to show you another demonstration, which is another good visual demonstration of when we lower pressure, what happens. In an AC system, we've got high and low pressure zones. When we take pressure away, we can also cause a refrigerant that normally wouldn't boil. And here's water sitting in this cup at room temperature, which is probably about 70 degrees. And the water is not boiling. If I want this water to boil, I'm going to have to put it on the stove and raise it up to 212 at sea level, right? So if I put it in my vacuum chamber and put the lid on it, and if we can get a good seal. So what we're going to do is we're going to turn on this pump. This pump will suck all the air out of the chamber, lower the pressure of the chamber down. Remember, in refrigeration, we're all about manipulating pressures. If we can manipulate pressures, we can change things from liquids to gases and gases to liquids, in which we can make them then give up their heat or absorb heat. So in this case, we're going to lower the pressure, and we're going to see if we can get this water to boil at this, 70 degrees it is. So we'll turn on the pump. The pump's running. We're starting to suck air out of this container. When we get it out, you'll be able to see if the water is going to boil or not. If it works like it should, the water should start to bubble and then it should start to boil. If I left it here and I allowed it to continue to boil, then it would actually eventually it would start getting colder because it would be giving up its heat. As it boils, it'll keep giving up its heat. It'll keep getting colder and colder and colder. That's the same principle that happened over here with the refrigerant. As it turned from a liquid to a vapor, it absorbed heat. This is going to do the same thing. So now you can see the water is boiling fairly rapidly. This is what would take place on the stove at 212. But when we take the pressure away, we lower the boiling point. And it's clearly boiling. The water temperature is only 70 degrees. So it's a good example of how you can manipulate the pressures and cause things to boil at different temperatures. When it boils and it turns from a liquid to a vapor, it does absorb heat, and that heat would be in here leaving the pump. But if this was an AC unit, I would capture that heat-laden vapor, and I would get rid of the heat, and then I would turn it back into a liquid and start the process over. So we're going to move down here a little ways, and I'm going to show you another demonstration real quick on what we do a lot of in this field is torch work. You can't be an air conditioning technician if you're not just a master at joining, fixing, and working with copper tubing, because that is the mainstay of what we deal with. So you have to be good with a torch. And I'm going to demonstrate just a real quick couple of things with copper. It's just a normal skill. In here, in this building, in this class, in this program, what you would do is you would learn this just like I'm fixing to show you, and then you would keep this torch going for the next 2 or 3 days. So probably 12 or 13 hours of having the torch in your hand. That's what's going to set you apart versus somewhere you go and you get a 30-minute, you get a piece of copper about that long, and after you do 1 or 2 brazes, you're done. They check off, now you're a torch master. You're not a torch master until you've spent a lot of time with a torch. So we're going to give you enough time to get your skill set down, and then you're going to you just get better and better and better. So copper tubing, pretty easy to work. I'm going to cut this one. We just regular old tubing cutters. You can get various different kinds. They come in different lengths. So in case you're working in tight quarters, you can use a different kind. We can do all kinds of stuff with copper. Copper is one of the easiest things to work with. So it cuts easy. It bends pretty easy. If you've got a copper bender and you want to bend copper, we can put it in there and we can get a nice 90-degree turn out of it. So copper is very easy to manipulate and make look very nice. By bending it, I avoided 2 brazes if I was to buy a 90-degree elbow. So now there's no chance of it to leak because I didn't have to make any connections. If I use a swagging tool to swag it together, I'll make another cut and I'll show you some examples. Now this happens to be 3/8 copper. We use a lot of copper in 3/8, mainly 3/8, I'd say 7/8, some 3/4. So here's the copper here. If I want to join the copper together, I can get a fitting and put in there, but I have to make 2 brazes. So I have 2 chances of a leak. If I swag the copper, then I only have 1 braze. So you have different types of tools you can do that with. One of them is a hydraulic swagger like this, which is very nice. On Amazon, you can get this hand tool that swags, and it's actually pretty decent too. It does a pretty good job. You can work it around in here and expand it. If you've got the hydraulic one and it's handy, it's certainly the easiest way. Once you get it to open up, it creates this little socket in there that allows the 2 coppers now to fit together. When I do that, I only have 1 braze. The nice thing about that is it allows me, if I'm brazing somewhere where it's hard to get to, I don't have to make a braze where I have a hard time. I can actually swag the one I want so that I'm able to determine which is going to be the easier way to go. So there's tools. We can ream this out, get the burr off of it. There's sand cloth. We can clean it up to make sure it's nice and shiny. We have our alloy that we use to join the copper together with different silver contents. And of course, we would talk about all that in class. Just to give a very simple, fast demonstration about how this works, I'm just going to braze this one piece up. So with my torch, we would have gone over all the settings with you, the safety settings on the torch. I'm going to leave this one on the bench for now. We normally don't leave them on the bench. So it's a skill that you learn. There's reasons that we set these torches at various pressures, and that's it's all about safety. We don't want anything to get hurt. So, all right, so I'm going to light my torch. I always light the acetylene first, like that. And then I adjust my flame to whatever is going to suit what I'm doing. If I'm doing a much bigger piece of copper, I can use a bigger flame. I can just add a little more fuel. I can get what I need. I'm looking for a nice sharp cone, and that looks pretty good. I start heating it up. The small copper like this heats up pretty fast. Copper melts at about 1900 degrees. If I keep the copper under that 1900, it won't melt. The alloy melts about 1400, so I don't end up melting a big hole in my copper if I'm careful. And this is, like I said, this is a skill. The more you do it, the better you get. If you take your time and you look it over really good and you see a spot that you think I could cap that off a little bit better while I got the torch in my hand, I could make that a little nicer looking, then you do. That's the time to do it, is right now. So I'm happy with that. I got in on it. I got out quick. Now I can take my rag and I can cool it off a little bit. And remember, this is where people make a mistake a lot, and they grab it right after they get done. And they get a pretty nasty burn. So the rags also allow me to protect if I had another piece, a sensitive piece, something up here that was going to burn, a Schrader valve, any other kind of service valve up here. I could protect it with the rag so that 1,000-degree temperature wouldn't get to it. So once I made my braze, I can look it over, see if I'm happy with it, and it looks good to me. You can see it's not going to leak. I've taken my time and capped it off. So this is what we want you to be able to do. We want you to be able to manipulate copper, make quality brazes, be able to swag it. As instructors, we probably come through here when you're done and let you pressure test it and put holes in it for you to fix. And then, of course, in our workbook, there's a whole slew of things for you to make out of copper and as part of the copper class. So we'll move on down, and I'll shut my gauges off as we move the camera. So we're going to move down to kind of like what would be the motor class, and just a super simple version of the motor class. Remember, we have about 16 subjects that we teach, and each subject starts out with a lot of this kind of like explanation, and then it goes, tremendous amount deeper than what we're doing here. We're just skimming the surface. When we get to the motor class, we want you to understand motors. We want you to understand how they work, how to test them, how to see if they're bad, how to wire them up, how to replace them, why they need certain things. So if there's something we can do to make this more understandable, we're going to do it. We have a lot of motors we've taken apart. We can pull the guts out of them. We can let you see how they're made. We have these little demonstrations like this one here, where we can turn it on and we can let you see the reason that it has certain things. This motor has a capacitor in it that they all have. Well, we want you to be able to see what happens, when the capacitor's not hooked up. The motor doesn't really have a lot of power when the capacitor's not hooked up. You hear the difference? Without it, I can make the motor go either direction. I can hold it with my hand. I can spin it one way or the other. With the capacitor in place, much harder, much more power, and now it turns the right direction every time. Just a simple demonstration like this will explain to you why when you get to some customer's house and the motor's turning backwards, it may not be anything wrong with the motor. It might be this $5 capacitor right here. So we want you to know how to check the capacitor. We want you to be able to see a motor in action when the capacitor is not being used. And then it makes all of this just make more sense. So regardless of the kind of motor, we want you to know how to use them, check them, replace them, get the blades off of them, the various tools. I'll grab my hub puller. Sometimes there's even tools, specialty tools we're going to make sure you get to see that allow you to pull the fan blades off. All of that is part of this class. If we move down here a little farther, you're going to see that we have electrical display board. Now, what I want you to take from this is that something like this is just a step one of many, many boards you would build. So you would take a sample board like this with nothing on it. You would get a box of components and wires and all this stuff, and you would go through your electrical book when we're in that electrical class, and this would be electrical controls, by the way, and you would build these boards. You would just build, there's probably 8 or 10 of them or more, and you would build them and you would test them, and then you would start understanding what this board is. This is the control circuit for a furnace. This is the outdoor condenser type furnace. And by building it here, your knowledge of the controls gets a lot better. I talked to a school when I started my school, and the guy showed me how they do their electrical control class. And he was actually proud of it. And I'm not real sure why, because they basically had a board like this pre-made, and everybody went by and he changed a couple of wires on it and you fixed it, and then you were done. That was it. They put the board away, you were done. And here you're going to get a blank board, a boxes of parts, and a whole lot of things for you to build. So you will be hours and hours on doing that. Now, what we have here is just another quick example of a skill, a necessary skill in the trade. And this would be the way that you remove cores out of an AC system. So when you go up to a unit, a lot of times when you take your gauges off of it, it can continue to leak. And you have to have this skill that enables you to be able to replace that bad part, what we call a Schrader valve core. And you have to be able to do it while the unit's under pressure. So you have to have the tool and the knowledge. Number one, the knowledge that the tool exists, and then the knowledge how to use the tool. And all those together is what sets you apart. And like I said, this is just one of dozens and dozens and dozens of things that you'll learn in here that we're just barely skimming the top on. To use a part like this, just to give you a real quick example, the system would be under pressure. I can't just take the part off. I'm going to lose all the refrigerant, which is, all sorts of bad. But I can put this kind of a special tool on, and I can then use this tool to see if I can get that component piece out, that little Schrader core out, and actually replace it while it's under pressure without losing any of the refrigerant. So we're gonna see if we can get it to come out. So I'll try it a couple times. Usually it takes a couple of times to get it. It takes about 7 turns, and that's usually the reason if it don't come out is you probably didn't turn it enough times. Or it didn't stick in the tool. In either case, you just keep trying until you finally get it. And I'm going to try it one more time. I've got probably 3 or 4 of these different Schrader core tools, and every one of them works a little different. But the key is I feel it right there. I'm on it. And if I've taken this one out too many times or I can't get it out, well, then I'll take it out after I get this tool back off. But we're going to try it again. see. Maybe this time. So there we go. So what happens is you just keep doing that process until you get it. And some tools are better than others. And after we've used them a few times, it gets a little hard to keep doing it. But the goal is, and what I just did is I was able to take this little core out while the AC unit would be in operation under pressure. I've got the valve closed, so I'm not losing anything. I would simply put on a new core on here, put it back on. And this is another reason we like you to do it in here several times, because it doesn't always go as planned. Now I can feel it got nice and snug. Turn my valve off. I can take this off, make sure it's not on there, meaning it's back where it should be. I can open my valve, nothing's blowing out, means everything's good. Now I can take my tool back off. I've replaced the core while the unit was running, put a couple new caps on there. That's a, you know, a $50 thing, and this is a super necessary tool. So again, one of the many, many tools and skills that you need. We're going to look here what this is. You know, when we get into heating class, we end up with these flue pipes, right, that go out the roof of the house. So this is what you see when you're walking by, or you're driving down the street, and you see these things sticking up over the top of the roof. Well, there's all sorts of things that go along with this that we're not going to do now, but in class you'll learn how high it has to go and how to figure out roof pitch and all those other things that would go with the flue pipe. But what I want you to do in the meantime is, as you drive past neighborhoods, just look up at the roof and see how many of them have this flue pipe sticking way up past the roof. Totally doesn't need to do that. It's just a sign of an inexperienced person. When we're into duct class, we've got all kinds of duct things that we have to talk about. And I mean, it's 100 times more than what I've got here on the bench. This is just a few of the components of duct class. You know, you've got the snips and the tools and the benders and the folders and all the various things that you have to know how to use. But more important than that is we have to have the ability of knowing airflow. How much airflow? How do I check airflow? How do I use a ductulator? How do I use static pressure tools? How do I know how much air? How do I use velocity, right? So we have all these other tools that go with duct that aren't the mechanical put it together tools. They're the diagnostic, set it, adjust it, balance it tools. You know, and we like to make sure that not only do you know the components, but you're able to build your own pieces. We want to make sure you can put together metal duct, and if you have you know, if you with your snips and some metal, you can make what you need in the field. We like you to show you how to use some of the specialty tools. You know, if it's a spot welder like this, we want to make sure that you've used it in class. If you're going to make one of these parts, you've actually been able to spot weld a piece together, and you see how it works. So all of this hands-on is what makes you a better person and a better technician. So we're gonna, you have enough space to pause it? Go around, okay. We're gonna move around and we're gonna look at some compressors. Compressors, if you remember when we were talking, compressors are the heart of the AC system. They should last 20 years or longer. They should definitely last the life of the system. So there's different types of compressors. Well, most people go their entire career and they have no clue. They might know the types, right? They might be able to say, you know, this is a scroll and this is a rotary, and you know, they might be able to identify them, but I doubt they've ever seen inside of one. I doubt they understand how they work, and more importantly, I doubt they understand the normals, right? So if you just know the normals, it sets you apart from so many other people. You know, if this is my scroll compressor, and the scroll compressor inside actually has a scroll, right? So look at that. See that? There's actually a component in there that's a scroll. That's the component that creates the pressure. If I have a scroll, then I have to know what's normal about this scroll. Where is it hot? Where is it not hot? Is it noisy on startup? If I touch the sides of it, should it be hot? If I touch the top, should it be hot? I have to know that, because when I get into a different type, like a rotary, like these guys, and I touch it and the whole thing is hot, if I don't know that's normal, I'm going to think something's wrong. Okay, but actually that's normal for this. It's normal for the scroll to be hot on top. When I move down onto the reciprocating compressor, which is more like, really more like a car engine. Look in there, see those pistons? This is really more like a big car motor. Certainly meant to last, heavy duty, cast iron. If I get into this, I need to know when I touch the outside of this that it shouldn't be hot anywhere. And if it is, that's not normal. So just those very simple normals help me a whole lot. I also have to know how to test these guys, right? If it's not working, I need to know how to determine that it's broke. So there's various meters, various methods of how to test them, not only to make sure they're not grounded, but that what is common start and run so I can wire it up properly. You know, if we look down here on the bench a little farther, we'll see, you know, that I've got some PVC laying out here. You wouldn't know it, but in most homes, the drain is just done wrong. Now the drain part costs nothing. It literally costs cents. The drain gets made wrong, and when the drain gets made wrong, the unit leaks, and it leaks on the floor and causes, you know, thousands of dollars worth of mess. So we like to make sure in here that we have you build them, that you understand them, which part goes where, why there's a vent, why it's a certain depth, why certain ones don't work, like the ones that everybody wants to buy from the supply houses, they absolutely just don't work. So we want to make sure you fully understand this. We actually have demonstrations that show this drain how it will not work if it's not proper. So we have demonstrations for that. We can show you pumps, drain pumps, and how they work. We can show how to check capacitors. You know, I told earlier, I mentioned that capacitors are one of the things that go out probably most of the time on the unit, and they're one of the cheapest things to replace. Well, there's all kinds of really nice tools out there to test capacitors. You can even test them with just the meter that's in your bag. So we have to be able to test these, understand them, and I mean really understand how to use them. We get into some of our specialty tools, and we get into things that we use like our gauges. Whether they're analog or they're electronic like this one, we have to know how to hook them up. Where do all the hoses go? Where do the clamps go? Why one set of gauges might be better than another, one type. And then you need to use them. You need to use them over and over again, do the calculations, superheat, subcool, follow the manufacturer's recommendations, and with whatever tools you need. There is a host of tools in this trade that make the job better. We can walk in a house, we can check for carbon monoxide. You know, we can look for leaks with UV lights. You know, we got instruments that can allow us to check humidity and dew points and just regular temperatures. We even have tools that are wireless that we can hook up to various points and we can see them on our phone. There is so many things in this trade that make our job easier. The trick is to know what you don't know, to know what the normals are, and to go somewhere like this where we're actually going to give you all those skills that you need. Pause it.